Welcome to Sukuma Tutorials. Today we are going to see how we can process the images, that is satellite images. So far we have seen basics of QGIS, that is how to create a line, how to create a polygon, how to create a point, and then how to make measurements and everything we have seen. These are all the basics. Now I am going to take you to image processing, that is how to process the satellite imagery and then make use of it for your research purpose. In the coming few classes, I am going to inform you about satellite imageries, how to get the satellite imagery, how to open it in QGIS, how to process it with various band combinations, that is a false color composite and true color composite, how to create it, then how to make unsupervised classification, how to make supervised classification. These are the things I am going to take. Once you have become familiar with these things, then you can process satellite data for land use and land cover, which you can take it to your GIS for further analysis. This is what I am going to take it. So be attentive to my future videos because it's very easy. We need not go for very big softwares. Using this open source software QGIS, you can also use unsupervised, supervised classification and classify the satellite data for your research work. So if you like this channel, please subscribe it, share it, like it. If you have any comments, you can add the comments to my videos. Thank you so much. Dear friends, welcome to Sukuma Tutorials. Before getting into image processing, we should know certain basics of remote sensing. Let us see it. Remote sensing is the technique of deriving information about objects on the surface of the earth without physically coming into contact with it. This is the definition. There are many platforms from which you can sense the surface of the earth. In our class, we are going to use satellite imagery. Drones are the latest platform from where we can get images. Since it is costly, we are not going to touch drone imagery now. So this is the basic. Sun is the energy source. From sun rays are falling on the surface of the earth, that is through B, that is a rays of sun rays falling on the surface of the earth on the sea. So it reflects back to the atmosphere through radiation wavelengths. These wavelengths are recorded in the satellite orbiting on the surface of the earth, about 900 kilometers, 600 to 900 kilometers above the earth. It is recording wavelength in different bands. After recording, it is sending to the earth station or communication satellite for storing it, where it is processed and then given to various agencies for image analysis and interpretation, where we do the image analysis and interpretation and then use it for different applications like agriculture, urban planning, groundwater, water resource management, etc. For image processing, you need to understand where the satellite imagery is available freely to download. Indian satellite imagery are available freely for some areas in Bhuvan site. The Bhuvan site is part of NRSE. Landsat imagery is available for the entire world in Earth Explorer site. In Google search, you can type Bhuvan and Earth Explorer and get into the website. For downloading the data, you have to sign up in the site. We should know the spatial resolution of the satellite imagery. Spatial resolution refers to the size of one pixel on the ground. It referred as high resolution images like Google Maps, medium resolution images like IRS imagery, Landsat imagery and Sentinel imagery. Low resolution images are there for climatic data. This is one scene obtained from Google Map. It's a high resolution image of part of Chennai. You can see the individual buildings. You can zoom to some level and then you can see the road layout, vegetation, alignment of streets, etc. very clearly. This is a 10-meter resolution of sentinel data of the same area. The pixel value is 10 centimeter in sentinel data. See, this is very close to the previous one. You can see the street alignment, all red colors. This is a false color composite imagery. Wherever you are seeing the red color, that is a vegetation. White colors are barren areas. Blue colors are built up areas. View of 10-meter resolution sentinel data. What you see now is the Landsat 30-meter resolution area of the same area of Chennai. This is also very useful for image interpretation, land use, land cover analysis. This is also false color composite imagery. Wherever you are seeing the blue color, violet color, that is a built up area. Red color refers to the vegetation. Deep water bodies are in black color. Features of the surface of the earth are recorded in different wavelengths, that is a reflectance in visible range of electromagnetic spectrum. It varies from 0.4 to 0.7 micron or micrometer. Normally 0.4 to 0.5 micron is called blue band. 0.5 to 0.6 micron is called green band. 0.6 to 0.7 micron is called red band. 0.7 to 1 micron is called infrared band. It varies from satellite to satellite. There will be small variation. Indian remote sensing satellite has got 4 bands. They are 0.52 to 0.59 blue band with 23.5 meter resolution. 0.62 to 0.68 green band. 0.77 to 0.87 micron is red band. 1.55 to 1.70 micron is near infrared band, but infrared band is about 70 meter resolution. All others are 24 meter resolution. Landsat imagery has got 11 bands, of which 8th band is panchromatic band. It has got 15 meter resolution. 1 to 7 and 9 are in 30 meter resolution. Band 10 and 11 are in 100 meter resolution. It varies from satellite to satellite. It is called spectral resolution. According to the applications, the requirements, you can choose the satellites and bands for image processing. All the bands will be available in grey tone or black and white only. We have to assign colors for different bands like red, green and blue. These are the basic colors given to the bands to see different features on the surface of the earth. Normally bands 7, 5 and 4 will be given red color. Bands 3 and 4 will be given green color. Bands 1 and 2 will be given in blue color. By giving combination of red, green and blue, you can create true color composite, that is a TCC, or false color composite, FCC. False color composite will be useful for visual interpretation, unsupervised and supervised classifications. This is a scene where you are seeing there is a true color combination on the left side. Top left is a true color composite. As if you are seeing from the sky, you can just see it, all vegetation in green color, built up area in grey color and water bodies in blue color. So this is the true color composite on the left side. Bottom right is the false color composite, because the vegetations are shown by red color and built up area is in light blue color. So these are all the basic things. In the coming classes we will see how we can create false color composite and True Color Composite. Hope this class will be very interesting for you. Looking forward to see you in the next class using QGIS, how we can create different band combinations, how we can open it, all these things we can see it. Thank you so much.